Okay, condensation of steam on horizontal tubes. Okay, this is the question. The condenser of a steam power plant operates at a pressure of 7.38 kilopascal. Steam at this pressure condenses on the outer surfaces of horizontal tubes through which cooling water circulates. The outer diameter of the pipes is 3 cm and the outer surfaces of the tubes are maintained at 30 degrees Celsius. So now the T surface of these tubes is at 30 degrees Celsius. So the question asks us to determine the rate of heat transfer to the cooling water circulating in the tubes and the rate of condensation of steam per unit length of horizontal tubes. So for the first question, we have to determine what is the Q dot. So to determine the Q dot, we know that we will use the equation of H as T saturation minus the surface. So from this equation, what kinds of information that already been given in the question and can be calculated directly. So we can calculate the directly surface area of these tubes, and then T saturation we can define or find it what is the saturation temperature for these problems, and the second one is Ts. So I will explain about the T saturation. Now, if water condense at 1 atm, the T saturation, okay, water at 1 atm, okay, it will condense. The T saturation is, for water at 1 atm, the T saturation is 100 degrees Celsius. So now we have a different information here, where we have this steam power plant operates at 7.38 kilopascal. So what you have to do is to determine what is the temperature at this pressure, because that is the saturation temperature where the steam in the power plant will condense to water, condense to liquid, vapor to liquid. So from the table, we know that at 7.38 kilopascal, the temperature is 40 degrees Celsius. So this is your T saturation. Okay, at 7.38 kilopascal, you have to refer to the table in the appendix. Take a look at 7.38 kilopascal, and then you will get what is the saturation temperature, or at this pressure you will know what is the temperature. That temperature is T saturation for this steam in this power plant, because it operates at 7.38 kilopascal. So different pressures will have different temperature, saturation temperature. So you have to refer to the pressure, okay? And then we already have the T surface, where at 30 degrees Celsius. Now what we do not have here is H, heat transfer coefficient. We do not have the information here. So what we have to do is to find what is the H. So this is horizontal tubes. As I mentioned before, the horizontal tubes and sphere, we will use these kinds of equation. So for the horizontal tubes, we will use the factors here is 0.729. So take out this equation to find what is your H horizontal. So directly use this equation. Previous video, I've explained that if we solve the problems for the vertical wall, okay, vertical plate, so we have to assume that it is laminar wavy flow first, and then find the Reynolds number. If it is in between 30 to 1800, then you can directly use H vertical wavy. For the case of horizontal tubes and sphere, it is a little bit different since we do not have to find what is the Reynolds number. So we can directly substitute all the values inside this equation. So this is the properties of water. So we know this information, and then the properties of water at saturated temperature, as I mentioned before, you have to refer at 7.38 kilopascal and then take a look at the temperature. The temperature is 40 degrees Celsius. So you have to determine the HFG and raw vapor at saturation temperature, which is 40 degrees Celsius. And then after that, the properties of liquid again will be evaluated at film temperature, 40 plus 30. 40 is T saturation plus 30 is the T surface, and divided by 2 you will get 35 degrees Celsius, and refer 35 degrees Celsius to table A9 to get all this information. So now, since this is horizontal tubes, we will directly use the equation for the horizontal tubes. Now okay. So for the H horizontal, I will not write down all the equation. I will give only the value for the H horizontal. After you substitute the value, you will get 9294 watt per meter square dot Kelvin. So this is your H horizontal, which represent heat transfer coefficient. So after you get this, you have to substitute into Q dot equal to H as T saturation minus T S. Okay, so now we have to find what is the area. Okay, heat transfer area is pi dl. So surface area AS, we will use pi dl. So after substituting the pi dl here, so we have pi d is 0.03 times with 1 meter. Okay, and then what we get here, ES is about 0.09425 meter square. So you already get your area, and after that you substitute into this equation, you will get your Q values is 8760 watt. So you already solved the first question here to find what is the Q dot. So since in this question does not mention about the length of your tubes, of these tubes, and the question does not mention any of information regards to the pipe length, so you may assume that this pipe length is 1 meter length. Okay, so that's why I've put it 1 meter as my length of the tubes. So if you do not want to put it as L, as 1 meter, so you may put remain it as L. So after that you rearrange the equation, it will be Q dot over L. Since we do not have the length value, so this result, the calculation value would be watt per meter, since we do not cancel out the length, since we cannot change the substitute the value of length because it is not been given in the question. So either you want to assume 1 meter or length would be remain as it is, so it is okay. Okay, now I will assume that the length of these tubes is 1 meter. So now we move to the next question where we have to find m dot. So from the equation of Q dot, we have not we have one here. This is the equation to find the Q dot. We have another one where Q dot is m dot H star Fg. So now we have to find what is the H star Fg. So from this equation, we have two different types of two different equations to define or to calculate what is the H star Fg, either number 1 or number 2. So both of these has a different condition. For the condition number 1, we will use this equation when we have the saturated liquid below than T saturation. And then the second one is superheated vapor. Of course, we are not dealing with a superheated vapor, therefore we will use the number 1 equation. So you have to substitute all the values inside the first equation, H star Fg, to get what is the value. And then I get the H star Fg is 2435 times 10 to the power of 3 joule per kilogram. So that is my H star Fg. So after that, I will rearrange this equation to get what is the m dot. So the m dot is q dot over H star Fg. So substitute, you already know the q dot value. Okay, substitute into this equation and divide with HFG here. So you will get the m dot is equivalent to 0.00360 kilogram per second. So you already solved the problem for the horizontal tubes. Okay, rate of condensation. Okay, before this, we know that this value, okay, we have the rate of condensation of steam per unit length. So if you remain the length as it is, then you will have this m dot, this will be kilogram per second per meter lah. Okay, if you assume 1 meter, then you will have these kinds of value. So this is for rate of condensation per 1 meter length. Okay, if you have kilogram per second per meter, and then that values represent, if you have a 10 meter length of steam tube, okay, pipe tube, and then you can multiply with 10 meter, then you will get that the m dot for the 10 meters. So now this value represent for 1 meter length. So my value is for 1 meter length. So please define, please state this info when you have these kinds of value, since you already assume that this is 1 meter in length. Okay, that's all for the condensation in the tubes. Thank you.